Imagine you're in an interview. The interviewer presents this scenario.
We are launching a new payment feature in our cloud application. How would you approach threat modeling and designing this securely?
Okay, I would like to clarify a few things. I'll assume our web app collects the credit card number, expiry date, and CVV. Our back-end payment service then processes this data before sending it to the payment gateway API, like Stripe, and we store the transaction status and the last 4 digits of the card in our database for customer history.
Correct, please go ahead.
Looking at the flow diagram, I'll cover information disclosure, that is data leakage. If the backend logs the full payload, like card number, CVV, then attackers, or even our own internal tools could access that data.
Wait, you mentioned avoiding data leaks in logs, but our developers need logs for debugging failed payments. So how will they debug the failures?
True, to solve this, we use log masking or redaction in the application. Before anything is written to logs, a logging filter removes sensitive fields like the card number and CVV. Instead, we only log safe information such as the transaction ID and sometimes the last 4 digits of the card, which helps identify the payment without exposing the full card number.
Correct, please go ahead.
Next is cloud misconfiguration. If our database is accidentally exposed to the internet, or if an IAM role is too permissive, it's a game over scenario. Next would be tampering. An attacker in the middle could tamper with the transaction amount before the backend sends it to the gateway. Then broken access control. Can an unauthenticated user, or user B, call the payment API using user A's transaction ID? Next would be injections like SQL on the backend processing database, or command injection.
If the payment API takes user input, how do you ensure it isn't vulnerable to SQL injection?
The main defense is parameterized queries or prepared statements, which ensure user input is never directly inserted into SQL queries. We can also add input validation and use least privileged database accounts to reduce impact if something goes wrong.
Correct, please go ahead.
The safest architecture is one where we never handle actual card data ourselves. Instead, we use payment gateway tokenization. Here's how the improved flow looks. In the browser, the user enters card details into an iframe or hosted field served directly by the payment gateway. The data goes straight from the browser to the gateway, bypassing our servers entirely. The gateway returns a unique, random token. This token is useless outside of our merchant account. The user's browser then sends this token to our backend web app. Our backend payment service stores only the token and a transaction ID. When we need to charge the card, we send the token to the gateway.
Tokenization is great for security, but what if the payment gateway goes down as we are not storing the card data? Does this design create a single point of failure?
To handle that, we can use a third-party vault that is independent of the gateway. The vault stores the card data and gives us a token. We then use that same token to talk to gateway. This keeps our servers out of PCI scope.
Sounds fair. Considering this as cloud environment, can you mention the solution in layered security controls?
Yes. First is transport security. We enforce TLS 1.2 or higher, using strong cipher suites for all traffic, both internal between microservices and external. Then, secrets management. We will never hard-code API keys. We use a cloud secrets manager or vault, and the payment service accesses it using an IAM role, managed identity, following the principle of least privilege. Then for API security, the payment service API itself must use strong authentication, OAuth 2.0 or MTLS. And strictly validate input schemas to prevent injection. We must also implement rate limiting. For observability, logs must never capture sensitive input, tokens, PAN. We implement monitoring to alert on anomalous payment failure spikes or unexpected database queries. Last would be DevSecOps. We integrate SAST and DAST into the CI/CD pipeline to catch vulnerabilities before they hit production.
In the secure design interview, it's not just about the right answer, it's about showing that you understand the trade-offs between security, compliance, and developer speed.
Follow AppSec Decoded for interview-focused security concepts explained clearly.